Now we will understand elastic collisions. Elastic collisions are those collisions in which momentum and kinetic energy are conserved. Inelastic collisions are those collisions in which momentum is conserved but the kinetic energy isn't. Okay, so we will take the same situation. This ball has a velocity u1 and this ball has a velocity u2. Now the arrow u1 is greater because the velocity u1 is greater than u2, because if this velocity is greater then the object can collide. This ball has momentum m1 u1, this has m2 u2. This is during collision. Now after collision, the two have exchanged their velocities, and this is m2 and this is v2. Now we know that m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now what I will do, I will bring together the velocities, the momentum before collision and momentum after collision of body A or mass m1 on one side, and the momentum before and after collision of body with mass m2 on one side. For example, I will bring m1 u1 minus m1 v1 on one side, because these are the momentum before and after collision of body with mass m1, and m2 v2 minus m2 u2. Why I did that? Because you can see I can take m1 common in this case. u1 minus v1 equals to m2 v2 minus u2. Now this is the conservation of momentum. Now since this is also in elastic collision, then the kinetic energy is also conserved. The formula of kinetic energy is 1/2 mv square. Now the ball A kinetic energy before collision is half, mass is m1, velocity is u1, and square on velocity. Ball B kinetic energy before collision, you have half, instead of m1 now you have m2, and instead of u1 you have u2 square. Now I will do ball A kinetic energy after collision. This is half m1 v1 square. You can see from here that if, for example, if the velocity is 10 meter per second, this is 2 meter per second. After this, the velocities have exchanged. The two have exchanged their velocity. The two will exchange their velocity. Ball B kinetic energy after collision is half m2 v2 square. So half m1 u1 square plus half m2 u2 square equals to kinetic energy after collision, half m1 v1 square plus half m2 v2 square. So what I do, I take half common, m1 u1 square plus m2 u2 square, half m1 v1 square plus, sorry, we did a mistake. Just like we brought together the momentums of the momentum before collision and after collision of ball A on one side, and the momentum before and after collision of ball to another side. Same here, we will bring together the kinetic energy of ball A before and after collision on one side, and the kinetic energy of ball with mass m2 on another side. For example, half m1 u1 square minus half m1 v1 square. This is the kinetic energy before and after collision of ball with mass m1 equals to half m2 v2 square minus half m2 u2 square. So this is the kinetic energy of ball m2 before and after collision. I take half common, m1 u1 square minus m1 v1 square. Half common is here as well, m2 v2 square minus m2 u2 square. Half and half cancel. This is equation 1. Sorry. Now m1 u1 square minus m1 v1 square equals to m2 v2 square minus m2 u2 square. This is v. This is equation 2. I take m1 common, u1 square minus v1 square, m2 v2 square minus u2 square. So divide equation 2 by equation 1. You'll see why. m1 u1 square minus v1 square equals to m2 v2 square minus u2 square divided by equation 1 was m1 u1 minus v1. It will be m2 v2 minus u2. m1 and m1 cancel, m2 and m2 cancel. Now u1 square and v1 square, they remind us of this, a square minus b square, right? Where a is u1, b is v1, so we square it. This is a plus b and a minus b, a plus b minus b, a plus b, so a square minus b square. So can I write it as can I write it as so a square minus b square? Can I write it as a plus b and a minus b? Why? a minus b plus b, a minus b. So this gives the a square minus ab plus ab minus b square. So it gives me a square minus b square as well. So I can write it as a plus b and a minus b. u1 plus v1 into u1 minus v1 equals to, same is the case here. Can I write a square minus b square? And a square minus b square can be written as a plus b and a minus b. A plus b, a minus b divided by u1 minus v1, v2 minus u2. So these and these cancel, this and this cancel. u1 plus v1 equals to v2 v2 plus u2. You bringing the u's and the v's on the same side. So this tells us relative speed of approach equals to relative speed of separation. Thanks.